Introduction to factoring. To get the idea what factoring is, let's talk about toy boxes. Let's say you're allowed to play with one type of toy that's in all the boxes. What toys would we be able to play with? The red toys only in 2 of them. Same with the gold box. The green toys in all 3. And the purple dots in all 3. With that in mind, let's pull out the toys we get to play with. Only the type of toy that's in all the boxes are the ones we get to play with. If we pull it out, what happens? We'll bring out this green toy and we'll pull out the purple toy. That means in our box here, this is gone, this is gone, this is gone, that's gone, that's gone, that's gone. What toys are left over after we pull out the type of toys that are in all the boxes? Well, we're left with these toys. That is factoring. You pulled out the toy types that are in all the boxes, and what's left over are these toys. You factored these guys out. That's what factoring is. And we're going to do the same concept with numbers and with variables, but that's the general concept. You look at what's in every single one and you pull that out. And what's left over is the thing that's been factored. Let's start with numbers. We're going to start with 6 and 10. First, let's find the GCF of each pair of numbers. GCF is the greatest common factor. To do that, let's break down 6 and 10 to its prime factors. So 6, how do we get 6? We multiply 2 times 3. 10, we can multiply 2 times 5. So I'm going to rewrite 6 and 10 here. 6 is 2 times 3, and 10 is 2 times 5. Using the same concept we did earlier, what's in both boxes? 2 is. If we pull out that 2, our box is going to have just a 3, and our second box is going to have just a 5. We factored that 2 out of those 2 boxes. That's what factoring is. You pull out what they have in common, and when it's left over, it's been factored out. Same idea, but let's go a little tougher with these numbers, 3, 12, and 15. We have to break these down. 12, I'm going to do 2 and 6. I'm going to do a little prime factorization tree. 6 can be broken down as 2 and 3. We're looking for things that multiply to get 12. So 12 is 2 and 6, and then 2 and 3. So we have 2 2s and a 3. 15, let's say 3 and 5. I think that's it. And I didn't do touch 3 because 3 is prime. You can't pull anything out of 3. Let's look at it again. What's in every single box? The 3 is. The 3 is in every single box. So we're going to factor that out. Let's see what's left over. Now, I know here we say when you factor out a 3, like, oh, there's nothing left in the box. But what we're doing is actually dividing. We're actually dividing all these by 3. So we're going to put a 1 in that box because when you factor it out, you divide. And over here, we have a 2 and 2, which is 4. So there's a 4 in that box. And over here, it's 5, like that. So we factor out a 3. When you factor, you divide. So even though it was a 3 and pulled it out, you're actually dividing by it. You have a 1 left over. This 12 divided by 3 is 4. And then 15 divided by 3 is 5. And with that same concept, we could do the same thing with variables. Right here, we have 2x, xy, 10xc. Let's break down the 10. The 10 is 2 times 5. Now, what is in every single box? It's actually not a number. 2 is not in the second box. There's no number in the second box. The only thing that every single box has is an x. We're going to pull an x out. And then what's left over in our boxes? We have a 2, we have a y, and we have a 10z. There we go. That's factored. Let's try it again here. What do they all have in common? If you look here, this has 3 x's. We have 2 x's and a y, and then we have a 2x. The only thing that's in all the boxes is an x, a single x. You can only pull out what they all have in common. I can't pull out 2 x's because this only has 1. It's just the x. Put the x on the outside, and then what's left over in our boxes. Over here, that x is gone. There's only 2 x's left over. Over here, this x is gone. There's only an xy left over. And over here, this x is gone. There's a 2 left over. And that's how you factor out an x. Keep in mind, when we're actually doing the math behind this, we're actually dividing. Let's xq divided by x gets you x squared. Over here divided by x gets you the xy. And over here divided by x, you get the 2. So that's a general concept. Now let's move on to doing it with actual mathematics. We're going to do the same thing here, but we're going to do it with actual math. 15x squared plus 18. We want to do the same concept. Okay, how do I break down 15? 15 is 3 times 5. 18 is 2 times 9, and I can break down 9 to 3 and 3. Let's look here. What do the 15 and 18 have in common? What's the greatest common factor? The only thing they have in common is a 3. So that's the biggest thing. We can divide both of these numbers by a 3. Let's do that. Let's pull the 3 on the outside. And when you factor, you divide by that number. We divide this by 3 and divide this by 3. In this first one, 15 divided by 3 is 5. And we have an x squared still. Over here, you'd bring down the sign. 18 divided by 3 is 6. And we just factored. That's all you could do. You can look here, same answer. That 3 is gone. Only the 5 is left over. Here, the 3 is gone. What's left over? 2 times 6. And if you want to check your work to make sure you did it correctly, if you multiply this out, you should get this. If you remember what we did last lesson, if we multiply these back out, let's do a little area model. we should get our original answer back. So here we have 3 times 5 is 15, 15x squared. And over here we have 6 times 3, which is 18, plus 18. And there we go. We have what we started off with. If you ever want to check your work, you should be able to get the same thing back. Okay, let's go on going. Let's go a little faster now. Here, instead of breaking down each one, I'm just going to ask us, what is the GCF, the greatest common factor of these numbers here? When I say that, this is saying, what could I divide all the numbers by, and what could I pull out of all the variables? The numbers, we look at here, they all divide by 2 because they're even. They actually all divide by 3, but the best thing, the biggest thing you can divide them all by is 6. They all divide by 6. We'll put a 6 there. Then we're going to work on the variables. This has 4y's, this has 3y's, this has 2y's. You can only pull out what they all have in common. The biggest number they all have in common. In this case, that's y squared. You can't pull out 4y because this only has 3, this only has 2. You can only pull out basically the smallest they all have in common, which is y squared. So that's my GCF. And what we're going to do is when we factor, we put that on the outside, and then we're going to divide all of these by my GCF, my 6y squared. Divide this by 6y squared. Divide this by 6y squared. Divide this by 6y squared. Negative 18 divided by 6 is negative 3. We had 4y's, we're taking out 2y, it should only be a y squared. 6 divided by 6 is 1. And we had 3y's, we're taking out 2 of them, so there's only 1 left over. And then over here, we have 24 divided by 6 is 4. All the y's went away. That is it factored. If you want to check your work, again, you can multiply back in, you should get the exact same answer. If we want to find the GCF of monomials, that's just the thing we're talking about, like what could you factor out of these things? What's the GCF? Look here. What's the number that divides 10 and 25? It's 5. My GCF here is 5. If I was going to factor this, that's the thing I would put on the outside. It's a 5. So we're just saying, what's the GCF? What would I factor out? 5. Here, look at my variables. I have 3x, I have 5x's. The GCF, biggest thing they have in common, is 3x's. Remember, when they have stuff in common, you can only pull out the smallest amount. X3. And look at the y's. I have 2 here, I have 1 there. You can only pull out 1 of them. That's my GCF for that. Okay, let's do a few more. Let's factor the GCF of these guys. My GCF over here. Let's look at the numbers. We have 10 and 12. What can they both be divided by? They both divide by 2. That's the biggest thing we can pull out. Again, if you're not sure, you could always do the prime factorization. 10 is 2 and 5. That's it for 10. 12 is 2 times 6. I could break down 6 to 2 and 3. I have 2 squared times 3. What do they have in common? All they have in common is that 1, 2. That's it. That's all they have in common. I'm going to put a 2 on the outside. To do the variables, we have a squared and a. When they share a variable, you can only pull out the smallest amount, which in this case is a. I have b and b squared. The same idea, I can only pull out a b. And that's it. That's my GCF. Let's factor it out. Factoring is just dividing. We're going to divide this by what I factored out. 10 divided by 2 is 5. I had 2 a's. I took 1 out. There's only 1 left over. And all the b's canceled out. Over here, bring down the sign. 12 divided by 2 is 6. I had only 1 a. Took it out. I had 2 b's, but I took 1 out. There's 2 b's up here. And then 1 canceled out. There's only 1 left over. And there we go. If you want to check your work, distribute. You should get the same thing you start off with. Let's do a couple of these real fast. My GCF here, 10 and 15. They both divide by 5. My x's, I have 3 here, I have 2 there. X squared. Remember, when they have in common, you can only take out the smallest amount. Y and y cubed, just the y. They both have a y, only take out the smallest amount y. We'll put this out here, and then we're just going to divide by that. Divide by 5xy. 15 divided by 5 is 3. There was 3 x's, we took 1 away. There's only 2 now. All the y's went away. Bring down the sign. The negative comes down. 10 divided by 5 is 2. Negative 2. I had 2x, I'm taking 1 away, so there's only 1 left over. I had 3 y's, I took 1 away. There should be 2 left over. And there we go. Let's look at the next one. x10 plus x9 minus x8. When they all share one, you can only take out the smallest amount. My GCF here is x8. When they all share the same variable, you can only take out the smallest amount. If they don't all share the same variable, you can't take it out. But if they share the same variable, you only can take out the smallest amount. Put an x8 on the outside. We're going to divide all these by x8. You had 10 x's, you're taking 8 away. There should only be 2 left. You had 9 x's, you took 8 away. There should only be 1 left. And then here, a lot of people put 0. Remember, you're dividing. x8 divided by x8 is a 1. You know you had 8 and you took 8 away, you're still dividing, so you get 1. Another way to think about that is you use the formula. Remember, it's top minus bottom. 10 minus 8 is 2. Top minus bottom. 9 minus 8 is x1. Over here, you get x8 minus 8. You get x to the 0. Anything to the 0 power is 1, except 0. That's how we get this. And the very last one here, we're going to find the GCF. Now I have 100 and 150. What's the biggest thing that divides both of them? It's 50. 50 goes into both of them. And then we're going to do the variables. I have 7 A's here. I have 8 A's here. 7 the smallest. I have 5 B's and I have 3 B's. B3 is the smallest. We'll put that on the outside. And then we're just going to divide by that. 50 A7 B3. 50 A7 B3. 100 divided by 50 is 2. All the A's went away. 5 minus 3 is 2. You had 5 B's and you took 2 away. B squared. Negative 150 divided by 50 is negative 3. I had 8 A's. I took 7 away, so there's only 1 left, and all the B's went away. And there you go. That's how you factor, and that's the lesson.